for like 3 hours. This is here, I'll show you. The page is the table on, the table in chat. The table I was looking at is on page 268. Okay, so for Ella, that's 268. And I just didn't chat that to everyone. So the table that you need is on page 268. All right. I will show you real quick though, that just so you get an idea. If you end up doing this, this is how you do it. Let's say, I don't know, let's pick a molecule like chlorine. Okay, let me go to my camera. And let's see, advanced camera share. So we're going to do this for chlorine. Here's my paper, and here's chlorine. And if I look on the periodic table of elements, chlorine has an atomic number of 17, and it has an atomic weight of 39 or 35.4. I just know that because of the atomic zoo, and this is, I never set out to memorize this. I never say to my students, memorize the first 40 elements in the periodic table. But I have a colleague who did that. So like, why do you have to memorize all that? You could just look it up. But here, this is something I just know, 1735.4. What we want to do is we want to figure out the Lewis dot diagram, and you want to figure out the electron configuration. Okay, I'll show you how to do the first one, but I'll do all of this next week. Okay, if you look at this, this is the number of protons. By definition, the atomic number tells you the number of protons. Well, the number of protons is usually equal to the number of electrons. So if I have 17 protons, how many electrons do I have? And if you said 17, that's right. So I have 17 electrons. All right, so I have 17 protons, I have 17 electrons, and we've done this before, but it's been a while. This is the atomic weight, and the atomic weight tells you the number of protons plus neutrons. So this is going to be 35 total, but I know I have 17 protons. That means I have 18 neutrons. So that's what I know. I have 18 neutrons, 17 electrons, and I have 17 protons. But you know, when you look at an atom, that there's a nucleus, and the nucleus has most of its weight in the middle. That's because all the protons are there and all the neutrons are there. So I have 17 protons, 18 neutrons. The electrons orbit the nucleus, but they orbit it in shells. There's a shell, there's another shell, there's another shell. So the nucleus here has electrons around it. It's those electrons in those shells that make up the size of the atom. The more shells you have, the bigger your atom, generally speaking. We did a graph of this earlier. The first shell can only hold 2 electrons. We have 17 total. The second and third shells can hold up to 8, but you fill them on the way out, from the inside out. So 2, I have 8 electrons there. I can have up to 8 in the third shell, but I only have 17 total. I got 2 plus 8, that's 10. So I got 7 left. We'll put those 7 electrons right there. All right, so the Lewis dot diagram tells you about the outer electrons. Those outer electrons, if you remember, called the valence electrons. These guys are trapped. These guys don't react. These guys are not on the outside. In order for them to be part of the chemical reaction, you got to remove all these. That's not going to happen. So the valence electrons are the ones that are a part of the reaction. So there's 7 of them. Well, the Lewis dot diagram is like this. The Lewis dot diagram has a dot for every valence electron. So this is how we do it. or 7 electrons altogether. Yeah, 1, 2, 3, 4. And then you add some more, 5. That's a paired electron pair. 6, 7. That's all you have. So sometimes you put an X there, which represents an unpaired electron. Actually, the X is the empty space. This is the unpaired electron. So that's a space. So you have space for 8. Remember, each of these is at 8, but 7 of them are filled up. So this is your Lewis dot diagram for chlorine. The electron configuration model tells us that these are not actually, these energy levels aren't circles. They're actually shaped differently. And so that's where you get this diagram that I put on Canvas for you. And over here, this tells you the number of electrons that are in each of these. They're not even, these are energy levels. These numbers correspond to these. So here's the first energy level that has 2 electrons. Here's the second energy level. The second energy level can hold 8. 2 plus 6 is 8. The third energy level also 8, but there's a third part that has 10. But you don't fill them up just like that. So what we do is we draw lines that go like this. Okay. And so the first one to get filled is the 1s. So if you have an electron, your electron goes on a 1s. Okay, this is the round ones are called the S shells. Okay. Now this second energy level right here is made up of a round one, plus there's a dumbbell shaped space right here that this whole, in the Bohr model, that this whole energy level represents. It's a dumbbell plus it's a circle. That's the P's, and the P's can hold 6. So I have 17 altogether. So I'm going to put 2 there. I'm going to put the next 2 here. That's 4. And I'm going to put the next ones here. So that's 6 more. So we got 2 plus 2 plus 6 is 10. Then I'm going to put 2 more in the 3s shell. Now I'm up there. I have 5 left. I'm going to put those 5 in the 3p. And I've got 1 space open. If you look, the next thing I'm going to do is I'm going to put in the 3d first. Oh, no. After the 3p, I'm going to put in the 4s. So there will be another circle around here. I'm going to fill up the 2s. I'm going to put 2 into 2s. And then I'm going to put the next electrons back into 3s. So that's what these arrows represent. Okay, so that's a quick explanation of that. And so to represent those 7, here's the way I would write it. I would write, I have the 1s shell, and then I have the 2s shell, and then I have the 2p, then the 3s, 2p and 3s. And then after the 3s, I have the 3p and the 4s. But I only have 17, so I'm not going to go to the 4s. I'm just going to go to 3p. So you write it like that. And then as an exponent, you put how many electrons are each one. So it's going to be either 2 or 6 max. Okay, so going from the left to the right, the first 2 electrons go here. That's what the 2 is. Exponent equals the number of electrons. So this tells me in the diagram that and this is called the triangle. So then you have 2s comes next. So 2s can only hold, all s's only hold 2. And put 2 electrons there. Okay, then I go to 2p. 2p can hold 6. So I'll put a 6 there, add them up. 2 plus 2 is 4, 4 plus 6 is 10. Got 7 left. So next I have the 3s. S's hold 2. So I'll put a 2 there. That's 10 plus 2. That's, what is that? That's 10 plus 2 is 12. I have 17 total. Means I have 5 left. Well, a P can hold 6. So I'm going to put in 3P and put the last 5 in there. And so this is the answer right here. The answer to the question is this diagram and this diagram for chlorine. Now chlorine, and this can be one of your 5. Let me stop screen share and go back to Canvas. Right here. It says choose one element from each of the different groups. Well, what are the different groups here? We have the alkali, which is the first row, the alkali earth, which is the second row. Pick a metal and a non-metal and a noble gas. So those are 5 different elements. Okay, what is this? This is a non-metal. Okay, you know that from the coloring activity that we did in grouping the different groups on the periodic table. So now you have to do one of the other 4, or you have to do 4 more, one in each of the other groups. This is the first column. This is the second column. This is anything in the middle, the transition metals. You have just done the noble gas, noble or non-metal, because chlorine's a gas. It's a halogen. It's in row 7. And then the noble gases are in the very last column on the right. So if you want to get ahead, now you have enough to do it with. But if you want to wait till next week, I'll do some more next week. Not next week, in 2 weeks. Whoa! And we are close enough to 6 o'clock to say, okay, let's just stop. Stop. Okay. And then Lois, I'm barely going to start 10. What does that mean? Let me see. Is 10 an assignment? I'm not sure what you mean. So anyway, are there any other questions? Oh, chapter 10. Okay, right. So chapter 10 is where all this is, I think. Let me look. Chapter 10. Chapter 10 is molarity. I think this is actually in the back part of chapter 9. So maybe you, Lois, since you've already done 9, you know something about what I said. But if you haven't done 9 yet, finish up 9 before you try to do this. It'll make you more sane, because if you don't have the background info, what I just said probably is like, whoa. But I have a sticky that says, put the Zoom video on so that you guys can do it. That's enough. I'm telling you, that's enough information so you can complete this assignment. Because I know some of you, I really need to get this assignment in. If you want to do it, then you can do it. But if you don't want to do it, you can wait 2 weeks, because I just changed the deadline. You saw me do it. All right, I'm going to go. I'm going to start driving. Yay. You have any questions? All right, good being with you, and happy Thanksgiving. I hope you get a turkey, because there's a shortage. But even if you don't get a turkey, lasagna is a great Thanksgiving food, and enjoy your week. And I'll see you in 2 weeks. Okay. All right. See you later. Alligator. In a while, crocodile.